addition, right? So we've got various derivatives of it. We've got addition, the noun, and I explained that. We've got to addition, the verb. We've got a view whose purpose is to let you do additioning, so it's called an additioning view. We've got objects that have entered into this wonderful world, and they're additioned, and we've got ones that haven't yet but might, and they're additionable, okay? Now think of the word to eat, and forget the fact that the English language has got some funny rules around it. Let's just suppose that, considering fruit types, we're thinking of apple, orange, and acorn, and we're considering the human perspective. I think it's fair to say that I could enjoy eating an apple. I could certainly enjoy eating an orange, but I would never dream of eating an acorn, right? I'm not a squirrel, simple as that. So I might say, without paying proper attention to the weird and conventional exceptions in English, I would say that, yeah, apples are eatable and oranges are eatable, but acorns are non-eatable, right? That's normal use of language. And then if I had a row of acorns on the desk, each one of them being an individual instance of the class acorn, I would easily see that acorn is not eaten or non-eaten. There's another non-eaten acorn. In fact, all those non-eatable acorns are inevitably non-eaten, right? And now I look at the apples, the row of apples on my desk, and I deduce from the fact that the class apple is eatable, then each individual apple is eatable, and there's 5 of them. I turn my back and there's only 4 of them. What's the explanation? One of those eatable apples has changed from being a non-eated apple into being an eated apple, yes? Because my colleagues whipped it away behind my back when I wasn't looking. Make sense? So you're comfortable with all the way those words are used. It's annoying that they, in English, use edible and things like that, but never mind that. You get my point. So now I'm saying what I was going to say, but here it comes. I'm talking about additionable and non-additionable object types, and I'm saying that not all object types are additionable, and I'm telling you the outcome up to and including 18.1. But let me give you the higher level principle. If you think of views, PL/SQL, and synonyms, then it's crystal clear that each object of any of those kinds is defined entirely by its metadata. When I say metadata, I mean rows in the dictionary. It doesn't have any quota-consuming data, right? So we might call such things code objects. On the other hand, if you consider an index or a table, or indeed, if you're that all-embracing in your thinking, a cluster, all those guys have occurring data inside them. They're certainly defined by metadata, but they're first and foremost data objects, right? And our basic concept is that axiomatically, data objects are non-additionable, full stop, non-negotiable. It's our concept that they be non-additionable. Our basic concept is that code objects of any kind are additionable. However, finite work takes finite time. And up to and including 18.1, the only object types among the code objects that are additionable are synonyms, views, and all flavors of PL/SQL, by which I mean schema-level function, schema-level procedure, package spec, package body, type spec, type body, trigger, and who would have guessed, library. You know, that funny little level of indirection that builds the bridge between a PL/SQL spec and an external C implementation that's used in connection with this xproc thing. People don't do much of that these days, but it is what it is. And when I say type and type spec, I'm talking about user-defined types. We often say UDT. If you go create or replace type T as collection of number, sorry, as table of number, that's the spelling, that is a UDT. That's a flavor of PL/SQL object type, and it is therefore additionable. Some UDTs might be additioned, others might not be. So as far as tables are concerned, given that they are absolutely irrevocably for all time axiomatically non-additionable, that means that you have to handle their versioning, which is your inner mind's intent, explicitly. And that's a good thing, because by doing it explicitly, we give you the control on the whole copy on write approach. And the good thing, therefore, is that if you want to create a whole new edition, the tables are outside that, and it's not like we copy all tables. If we'd said we copy tables semantically and then tried some game like I told you before, you can see where that would lead us with all manner of who knows what. You know, you insert a row in one table, but the other one now has got to diverge. How does it diverge? The block, oh, it gets all crazy. We just didn't do any of that. We said tables are tables, you deal with them, and it's good for you. So if you insist that you get a full separate copy of your table in the new edition, you can do it yourself. You'll have to give it a different name, but then you map it into the editions in question with this thing we call an editioning view. So an editioning view is the thing that maps a non-editioned table into the wonderful world of editions, and it can map it differently in each different edition according to what you want. Okay? So now I'm going to give you the formal rules about editioning views, and we're coming up with some more axioms here. The first axiom is really saying two axioms. One, let there be editioning views. We're inventing that idea. And an editioning view is first and foremost something special. You do go create or replace editioning view v as, the keywords there in the syntax. It's its own animal. You can see in metadata that it is one of them. There's even a DBA editioning views view family, so you can get specific facts about that kind of animal. Now, if you're going to create one or have one, then it's going to be defined by a subquery, as are other views, but the rules that govern the power of expression of this subquery are very, very strict indeed. They're draconian. And they are this: the only power of expression that the subquery that defines an editioning view can have is projection and, if you please, rename. In other words, you can go create or replace editioning view v as, select C1, C2, C3 as dog, C4 from T. And by the way, the relation, the base relation for an editioning view must be a table. It can't be another view. Since I said project, it can only be one table. And you don't have to ask, please, can I have an order by? No, order by is not included in the definition of projection. Projection is just identifying a true subset. We don't let you have 0, but we let you have 1 up to all. That's it. So, next axiom. You can't have more than one editioning view for a particular table in a particular edition. Why? Because we like to say that the editioning view is the logical projection of a table into an edition. And if we didn't have that restriction, you couldn't use the word the with that confidence, you know. It would be nonsense to say that the set of editioning views that cover a table in one edition are the possibly many projections of what it means. That just makes no sense. So that's why we have it that way. We had a fight internally, almost ended in a fist fight, with some engineers who didn't understand the detail of this, insisting that it would be good to have the possibility of many editioning views over the same table in the same edition. We just had to hold them back all the time. Trust us, this is our axiom system. We invented it, we know it does what we need it to do, and any perturbation will completely mess it up for our purposes. Keep off it. So the next one, again, I won't tell you now why we worked this out, but the editioning view must have the same owner as the table's owner. Now you're beginning to get a hint of something, so I'll just give you a pointer to where I'm going. We didn't find a way to put editioning views in a different namespace. For various reasons, that was unworkable. So editioning views, like other views, they're in namespace 1 as in tables. So the editioning view that covers a table can't have the same name as it. And I'm also saying that by implication that you didn't used to have editioning views, of course, because you've never heard of the idea. Now, in order to use EBR, you have to have an editioning view in front of each table. I'm hinting at it, and I'll say it more forcefully soon. Therefore, you've got to do something. You've got to get them in there, and you've got to get them in there with different names. How's all that going to work out? I'll come to that. That's just a little pointer for you. You've now got a sniff of the notion that there has to be a deliberate step, a somewhat invasive step, of adopting EBR mechanisms into your app. In other words, buying the entry ticket once and for all into the wonderful world of EBR, such that thereafter you can do zero downtime application upgrade. So next point, this is critically different. This one here is a rule of proper practice. It's not an axiom. Right? All the other stuff that I've said, it's axioms of our invention. And now we're saying if you want to use the invention according to how we intend it to work, you must do that. We can't force you to do that, but if you don't do that, it will end in tears. Right? And the rule is application code should never, ever, ever mention the name of a table. That's one way to put it. The additioning view is the guy who mentions the name of the table. Thereafter, everyone mentions only the names of additioning views because they're the logical projection of tables into the additions. All right then. So if I'm putting my money, if I'm saying that, I'd better put my money where my mouth is, because after all, triggers are an example of application code. So it must be possible now to have table-style triggers before and after statement, before and after each row on an additioning view. And indeed it is. We just implemented it, designed it, required axiomatically that it be such and implemented it so that you can have table-style triggers on additioning views and you cannot have instead of triggers on additioning views. So in that sense, additioning views are more like tables than they are like views. But in all the other senses, additioning views are views. They're most certainly additionable objects by virtue of being views. Little detail, if you insist on using an optimizer hint, maybe you've heard that the fashionable way to identify an index that you'll use in the hint is not to give its name, but rather to give, without EBR there, the name of the table and the column list that you used when you created it. In a way, you could say that when you go create index some name, and then T parenthesis column list parenthesis, you've really named it by T parenthesis column list parenthesis. Why do you need another name, It's almost convention. And in your optimizer hints, use that second style of naming, and then, in the wonderful world of EBR, spell that not as the name of the table and the columns there, but as the name of the additioning view and the columns as they appear in it. Right, I'll leave the last point, it's unimportant. Now then, you can see another source of discomfort. This is where the self-styled DBAs come along, big beards blowing in the wind, and they say, well, views ruin performance, so you can't have EBR. I know that to be the fact. Views are bad, so you can't have it. And so you have to be able to reason that because additioning views are very special kinds of views, there's nothing to worry about. The reasoning is simple. Here's our assertion. Any SQL statement that refers to one, at least one, maybe several, additioning views will get the same execution plan as the statement you'd get if you replaced each of those references by hand, in other words, pencil and paper, with the reference to the underlying table. In that sense, you can see that we're considering an additioning view at SQL compilation time to be like a macro, yes? You could do it yourself. You could get a SQL statement. You could see with your eyes that it was properly syntactically correct. You could see with your eyes that this identifier here is going to be the name of a table or a view. You look in the dictionary, you see what it denotes. Ah, it's an additioning view. You look up the metadata for the additioning view. You discover the table under it. You look up the metadata for the columns in the additioning view, and you see, are there those columns in the table? Job done. You do the macro substitution on paper, and you've got a new SQL statement with the identical semantics. Okay? And surely it's easy to believe that the former and the latter, the one that mentions additioning views and the one that no longer does because you did macro substitution by hand, you can see that they have the same, or it's proper that they would have the same execution plan. And that's the clue. SQL compilation, at its very first step after basic syntactic correctness checking, goes for the name resolution, finds an additioning view, treats this as a macro, replaces it with real table stuff. That's water under the bridge now, so it goes on. You're bound to get the same execution plans. That's the way to reason it. If you want another way of looking at it, at Salesforce, when they adopted it, the engineer who adopted it was completely convinced by that reasoning. The people whose job it was to test performance, and that was their full-time job, were not going to believe it until they'd, showed that they had important jobs. So they tested it all with real application testing, and sure enough, they proved or at least they failed to disprove anything about our claim. In other words, there it was. They were happy that you can use, to put it very carefully, you can put an additioning view in front of every single application table you had, and it won't make any performance problems at all, nor clearly semantic problems. It's a painless thing to do. So now that's, if you like, a clue to the whole business of adoption. We're telling you, if you want to enjoy EBR, you've got to take what we'll see immediately as a downtime exercise, put an additioning view in front of every table. Okay then, moving on. This is now going to be quite subtle, but you can manage it. If I can manage it standing up, you can manage it sitting down. An object whose type is non-editionable is never editioned. In other words, those non-eatable acorns never end up being eaten. Obvious that. On the other hand, as we saw with the apples on the desk, an object whose type is editionable is not necessarily yet editioned. What do I mean by saying something is editioned? I mean, when it is, it now magically has the possibility to occur several times in the database, once in each of the editions that there are, 0 or once in each of the editions that they are, as I explained. So then, the point then is that we had to have some special switch, and the switch is the owner of an object whose type is editionable must be set. It must be editions enabled so that then that object itself becomes editioned. Why did we need that? Why did we not just make it such that if you upgrade to or install 11.2, you find immediately that all views, all PL/SQL, all synonyms are just magically, instantly editioned? Why didn't we do it that way? Why did we have this extra level of complexity where you have to opt in actively? It's because of this red guy. And I'm just going to sort of unashamedly call, whoops, sorry, wrong knob, call the red guy a theorem, as you see. And it says, if I don't pronounce the word ordinarily, which is in italics, I'll come back to that later, it says a non-editioned object cannot depend on an editioned object. Why do I say that as a theorem? It's because of the axiomatic definition of name resolution among editioned objects. Remember I said that if I've got an edition view v, create or replace view, scott.v as select, and then I've got an editioned dependency parent as select something from blake.w, where blake.w is an edition view, I find my dependency pendant in my own edition, right? Now, considering the editioning view, it's kind of going the other way. Is our man, the videographer, doing his job there? I may have run across the other side of the room and back. I'd have gone off screen. Where was I? What happens when a... see, I'm watching everything. What happens when a... And I'm standing up. What happens when a editioning view needs to do its name resolution? There's many editioning views across all editions, each with its own same owner and name, but they all need to select from a table. There is only one occurrence of the table scott.emp, so there's no paradox, no ambiguity. They all just find it, because there's only one. This is the paradox. You have an editioned UDT called scott.u, and there's one in each of many editions. And now you think it'll be good sport to have a table whose data type is given by scott.u. So you try it. The paradox, the irresistible force, immovable object thing is this. The irresistible force is, well, you said my type is scott.u. Right, I irresistibly want to do my name resolution. and the immovable object is, you've got to find the one that it is. But there's many. So it's just a paradox. Because it's a paradox, we cannot allow it. So if you did it in reverse, you know, if you already had an additioned UDT, scott.u, occurring many times, and you tried to go, you know, create table or the alter table thing, and introduce a column whose data type is scott.u, we'd give a clear error. And the error would say, in equivalent words, you can't do that, because if you did, you would violate the prohibition I just said. The prohibition that says a non-editioned object cannot depend on an editioned object. And to save me repeating that long load of words every time, we call it the NE on E prohibition. Yes, it is prohibited to have an NE on an E. It's prohibited to have a non-editioned object on an editioned object, depending statically on an editioned object. So then, think of it when you want then to enter the wonderful world of editions, and you want your scott.u to become editioned. If you already have a table T who has a column based on the non-editioned UDT, and you want to go alter, this is Scott, you want alter user Scott enable editions, if we allowed that, we would end up in, you know, paradox city, wouldn't we? So we have to say, can't do that. So if you go alter user Scott enable editions when Scott has a UDT, scott.u, who gives it shape to a table anywhere in a column of the table, then we just have to say, sorry, you can't do that. That command fails because, should it go ahead, you would have violated the NE on E prohibition. Still with me? There is actually a possibility that you might say, you know, alter user Scott enable editions, I really, really know what I'm doing. Go ahead and do it. And that's spelt obviously F-O-R-C-E. And if you did that, we would go ahead and do it. The outcome would be that Scott now is indeed now editions enabled, and every object it owns whose type is editionable is now suddenly an editioned object. So what about the table? We can't have the paradox, so we had to destroy the table. Simple as that. The table is now invalid. And if you've ever wondered, the only operation that's allowed on an invalid table is to drop it. So it's as if it's been vanished already. Okay? Of course, you'd never do that by accident. You'd know what you're doing all along the way. So you can see that at least in 11.2, there was a possibility that in order that you enter the wonderful world of editions, you were kind of stuck with some problems to solve. Because if I didn't say it clearly enough before, I'm saying it now. The only value you get from editioning views is exactly that they are editioned, and you can have the same name, scott.x, as an editioning view in each of many editions. So we force that on you simply by saying that the owner of an editioning view that you're about to create must be editions enabled. So this is the reasoning. To be fully into the world of editioning, you have to have an editioning view in front of every table. Ergo, the owners of those tables have to be editions enabled so you can get the editioning views in. And in fact, you want all your owners to be editions enabled because you want the whole game to work. But they didn't used to be. So you have to editions enable them, but in editions enabling them, you run the risk of violating this paradox. Therefore, you have to think of it. Now in 11.2, it could be quite an effort. Suffice it to say, eBusiness Suite had all these deal breakers, these NE potential violators, and they had to do a whole dance of messing around. I won't even bother to explain that because it was always on our plan to make that better, and we made it better in 12.1. I'll explain now how we did that. But before I do, I will say that anyone who isn't using EBR yet and plans to adopt it would be mad to do it in 11.2, given now that 12.1 has been out for so long, and given that 11.2 is quite likely to cause pain, and 12.1 removes the source of that pain. It's as simple as that. Now, what are the mechanisms? Well, think of those apples again. Suppose you got them, 5 of them, that's why I needed a separate table. You got your 5 apples around here, and you pick each of them up and you think, oh my God, what a delightful eatable apple. Same again. Oh, I'm really going to eat that. What a lovely eatable apple. One of them, you suddenly notice, wait a minute, it's got brown spots all over it. Bring it a bit closer. Oh my God, they're not spots, they're holes. And you've come to the conclusion that this apple is completely eaten through by grubs, right? It's completely messed up. So you think, oh my God, that's not an eatable apple. And you can even stick flags in them. Eatable, 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 non-eatable. So in other words, though the class apple has the nature that in general its objects are eatable, or we would say in plain English, apples are eatable, individual occurrences, individual instances of class apple may or may not be eatable according to something you've worked out. So you'd label them eatable, 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 non-eatable, eatable, eatable. And so it is in 12.1 with editionable objects, right? Pick an example. UDTs. UDTs are, in their general nature, editionable. If you editions enable the owner of an EDT, it's like eating the apples. They suddenly become editioned UDTs. Except there are some you don't want to become editioned because they'd mess up the NE on E prohibition. So you stick a little flag. This UDT, among the others, this one that I care about, is not editionable. So in 12.1, there are DDLs you can do who have the effect of sticking the label in the apple. You know, you're saying this UDT, altered blah blah, some syntax. I'm saying it's not editionable, which means when its owner is editions enabled, it will remain uniquely among its peers, not editioned or non-editioned. Did you follow that? Good. And that means that if you have table on UDT and you want to editions enable the owner of the UDT, in 12.1, the first thing you do is set it non-editionable. Everything works out fine. There wasn't that possibility in 11.2, though it was in our minds even before we built 11.2. It's just we had to wait because finite work takes finite time. So that's how we do UDTs. I won't say any more on the fine detail of it in the interest of time. If you haven't thought about it, public synonyms are another example of the same game, because a public synonym is actually nothing other than a synonym like all other synonyms who happens to be owned by an owner called Big Public. It's as simple as that. And if you really wanted to amuse yourself, you could go create or replace synonym Big Public, in other words, because public's a reserved word, create or replace synonym double quotes, Big Public, double quotes, dot S as blah, blah, blah. And sure enough, you'd have a public synonym in your hands. Now, what is it about that that's rather special? Well, public is an owner that Oracle ships, as are sys, system, CTX sys, and half a dozen other things, MD sys, the list goes on. If you tried for sport, alter user sys enable editions, it's entirely non-risky, you'd immediately get an error saying, I'm terribly sorry, I don't let you do that. All the users that we, Oracle, ship, we're just holding them back. We're not going to let you make them editions enabled because it would cause too much chaos. Trust me, it would. So public was just one of them in 11.2. Oracle runs it, and we just made it such that all public synonyms were inevitably, therefore, non-editioned objects because you couldn't editions enable public. And that was a pain too if you had, as you might well have done, public synonyms denoting your own user objects. Like tables are all right, but if you had public synonyms denoting procedures or views, you know, that would have been a problem. We fixed that by making it such that in 12.1, either on upgrade to it or on fresh install, the Oracle shipped user public is editions enabled out of the box. But every public synonym that exists at that moment of either upgrading to or installing from scratch, 12.1, every public synonym that exists at that moment is already pre-flagged to be non-editioned or non-editionable and therefore not editioned. Got that? But that means if you later want an editioned public synonym, you can by all means get it by going create or replace editionable synonym S as blah, 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 and then it will instantly become an editioned one because its owner already is editions enabled. Make sense? Okay, that was that. Now, the next thing is quite a brain teaser. Sorry, wrong direction. So it's this, materialized views, indexes on virtual columns. First, a little note. People sometimes talk about a function-based index, or even worse, a functional index. I wish I could just get hold of them and wash their mouth out with soapy water. The better term is an index created upon an expression, or if you want, an expression-based index. Now, the expression could be A plus B, where A and B are the names of columns. That's a perfectly fine expression-based notion. You can create an index on A plus B. You could also create it on square root of something, or lower. That's a popular thing to do. Square root and lower, they're functions. They're SQL functions, though. The interesting case for us is when the expression that is used as the defining expression upon which an index is built contains a reference to a PL/SQL function. That's another case of a NE upon potentially an E, as you see. But the first thing I have to say is we don't like expression-based indexes these days. We rather prefer an index upon a virtual column where the virtual column is defined by the expression you had in mind. Why? Obvious reasons. You can get statistics on the virtual column and you can't on the other. So let's just assume, orthogonal to EBR, you've understood that wisdom, and at the moment you want to adopt EBR, you simply don't have any indexes that are based on expressions. Rather, the only indexes you have are based on virtual columns, and you have your statistics as well, because this is the thing to do. Now, the paradox is that the virtual columns expression might contain a reference to a PL/SQL function. And then with the index on that, you'd have a potential violation. Still with me? So we've got to deal with that. Now, it's exactly the same situation with the materialized view, because materialized views are not among the set of editionable objects that I mentioned. Therefore, materialized views, every materialized view is itself not editioned, but a materialized view can refer in its defining subquery either to a regular view, which is editionable, or to a PL/SQL function, which is editionable. So those two cases, they're much of a muchness with respect to what I'm saying. I need only describe the story for the virtual column case, and I've given you the story. Now, the interesting thing about them both is that in one use of them, their value is indirect. You just have a virtual column there with a certain defining expression, and then you do a SQL statement who happens to have that expression in it. And the optimizer works out that that's what you did, and notices, aha, one of the plans that I might choose among would be to evaluate the values I need, not by running the function, but by taking, evaluating the expression in real time, but by taking the values out of the index, yes? In other words, a virtual column is a possible candidate for query rewrite. And it's the same with materialized views when you have them refreshing on commit, or when you don't have them refreshing on commit, but you don't care about getting the right answer. You can state that this this materialized view is a candidate for rewrite, yes? So that's what we're talking about. We're talking about virtual columns as candidates for query rewrite in the presence of additions. And clearly, you could get out of the paradox there too by setting up the function that's involved in the virtual columns defining expression as not editioned, just by using the same mechanism as before. Why did we feel we ought to do better than that? It's because we felt that, also with the views involved in materialized views, there was real pressure, especially from the e-business suite people, to have them as additional objects, because it was useful to be able to change them EBR style. They just didn't like that idea of giving up that. So we had to revisit that prohibition. And if you'd been, let's say, had time to have a shower, go home and think about it and come back again, I'm sure you'd have tried to catch me out with that. And that's where the ordinarily comes in. I'm saying this, watch my lips, I'm saying that that has to be a theorem, because how else would the name resolution happen? When a non-edition table needs to find the one among many, UDTs it depends upon, let's not use that example. When the index, which is a non-editioned object, needs to run the function as part of evaluating the expression so that it gets the values to put in itself, it needs to choose which one among the many to use, to run. How can it possibly do that? Because the rule is it looks for the one that it needs in its own edition. And because it's not in an edition, it can't find anything. Paradox, therefore we don't allow it. That's what I said, isn't it? And any one of you, if you'd gone home and thought about it, could have come back to me and said, well, why don't you just tell it then? You know, why stop at that point? You said it can't find the one it wants because it's not in an edition, it doesn't know what to do. Just tell it what to do, for God's sake. Give it an extra piece of metadata that is the edition it's supposed to look in. And of course, we had that in mind even before 11.2 as well, but we couldn't do it until 12.1, and then we did, and that's it. So there is now metadata for a virtual column, which is passed to the index, or for a materialized view, which is what we call the evaluation edition. Why is it only that? This? What's this about? This is, if you like, super luxury. If we didn't have that, there'd be a little bit of a discomfort in the following situation. Sticking with a virtual column, suppose the function involved in the expression for defining a virtual column and hence getting the values of an index on it, suppose it's in a package spec. And suppose you want to do EBR on the package spec and make a new version of it in the next edition, a new occurrence, a new definition in the next edition. The reason you want to do it is to introduce a brand new procedural function in that, right? You've got no interest in the function, you're just going to leave it as it is. But you have to make a new occurrence of this object in the next edition, exactly to introduce the other procedure or function, okay? So you've got two different definitions of the package that exposes the function in question. Which should the virtual columns index use? And you know the answer is it doesn't matter, because they're both semantically identical. I humanly know that they're the same. You don't, I'm telling you. So, you know, you, the Oracle system, would think, well, I got two different definitions, they must be different. But you know the inner workings, and you know that those two Fs within the package do have identical semantics because you didn't change anything. So the way you get around that in an EBR exercise is you, at some point, say the evaluation used to be the old edition, now it's the new edition, knowing that that makes no practical difference. But during the hot rollover, you want the optimizer to be able to see the index as a ultimately the index as a candidate for query rewrite in either of the two editions. So you want to be able to say, I'm telling you, I'm promising you that you can do that. And the way you promise that is with the usable edition range. So if you were doing now this from scratch, you've already got everything editions enabled just as you want it, and you suddenly decide you're going to have a brand new virtual column on a particular function which is exposed in a package spec, then you would set up the virtual column, you would put its evaluation edition equal to the edition you're in, you'd set the range capped at the old end where you are, and at the other end it would be just wide open, right? And then if at some later stage you went through it, you know, patch after patch after patch, where you didn't change the semantics at all you would do would be to, as the closing stages of the EBR exercise, update the evaluation edition to point to the next edition, which is an innocent thing to do. If eventually you came to really wanting to change the semantics of this function, what you then would do in the EBR exercise for that is cap the usable range of the existing index at the old edition that's now become the leaf of the new edition, and put in a new virtual column whose evaluation edition is the next edition and whose range is capped at that end at the bottom and is open there after the top. And then the optimizer would see, this one is a candidate for me in this edition, and this other one is a candidate for me in the other edition. You with that? See that? Notice that you don't use the name. Nobody uses the name of the virtual column in this context except the optimizer. Under the covers, it discovers it on the fly at plan computation time as that step during SQL compilation. I apologize if this is too much stuff coming at you with too much words, but I promise you that if I tried to show you code examples, it would be the whole afternoon, and I don't think you'd understand it any better than just at this level. So if you're feeling that's just too much, just take away this high-level point, and it's this. EBR is functionally complete with respect to all manner of things you might want to do. It's functionally complete with respect to having tables based on UDTs. It's functionally complete with respect to having virtual columns upon which there's an index where the expression involves a PL/SQL function, and you want it to be additionable. We can handle that too. And when the time comes that you find yourself in that situation, first thing to remember is, yes, there's a way to do that. Got something to do with evaluation additions or something. You read that part of the docs and then it'll come clear, because you'll have a real problem. You'll have the context of needing to know the solution. Make sense? So I think now I should just do a time check. I've been at it roughly 90 minutes, haven't I? A little bit under. Let's just see what's coming up next. What's coming next is cross-edition triggers. This is so simple, I'm going to do it, and then we'll stop for a break. Make sense? Is that good? Yep, okay. But it'll be a mini break, I guess. So then, cross-edition triggers. They're big anticlimax. We have to have synchronization. We have to notice when values in one column fires, and we have to correspondingly see that value and do stuff on it and put it into other columns, yes? How do we do that? The obvious way to do that is in a trigger. Why do we like triggers so much? Because triggers have been implemented for the last 3 decades or something, and whatever paradoxes, race condition type of things that need to be sorted out, they've been sorted out since the dawn of time, and they're robust, well-tried and tested. Tom Kite in his day used to delight in explaining how triggers worked. In this scenario, you've got 2 sessions in parallel. Each does an update statement on a big table. Each identifies a large subset of the table's rows, but they're different subsets. It takes some time to process each of those subsets, and the subsets have an intersection, and there's a trigger on the table. What happens? One of them reaches a certain row first, and the trigger fires, but you haven't yet committed, and you might roll back. The other one reaches the same row, and the trigger fires. The values are different at each time. What happens there? It's simple. The right outcome happens. I don't even know if it's necessary to understand the details. The point that Tom Kite always made was you couldn't do anything out of the transaction in your trigger. If you sent an email in that, God knows what that would mean. But if you just stayed transactional, no problem. And of course, people who are using EBR know what they're doing, so there's no problem. So first and foremost, cross-edition triggers are triggers. Why did we even bother to go further than that? Well, we wanted to make it comfortable, and we needed certain properties as well in addition. It's rather hard to explain in the time I've got now. So suffice it to say, rather than forcing you to detect yourself what's going on where, and which trigger should fire and which trigger should not, we simply give you 2 kinds of trigger: forward cross-edition trigger and reverse cross-edition trigger. And setting the stage for the rules, first thing to notice, of course, is that I lied before slightly when I said the only animal type on the whole planet that can even know that tables are there is editioning views. I now add to it editioning views and cross-edition triggers. Clearly, a cross-edition trigger must be created on the table because it needs to see columns that are uniquely visible in the old edition, as well as columns that are uniquely visible in the new edition. So it couldn't go through the views because it wouldn't see the right stuff. It has to be right on the table to see the old world and the new in one glance. All right. Now, triggers have special firing rules, and the firing rules just rely on you following the paradigm. And the paradigm is that when you're going to do patching EBR style, to save breath, I'll say when you're going to do an EBR exercise, you create a new edition. This is the session doing the exercise, creates a new edition and switches into it straight away. And thereafter, you stay in that new edition, and everything you do is in that edition, including the DDLs you use to create cross-edition triggers. Cross-edition triggers, too, are editioned objects. And so when you create one, it's going to be in edition. The forward and the reverse cross-edition will both be in the new edition. And we assume that when we assumed it when we defined our firing rules. And they also assume this is almost tautological. If you think of the phone number example now, the old style phone number is going to be projected by the editioning view that is existing in the old edition, and the replacement new pair are going to be selected uniquely by the editioning view in the new edition, right? The old single column is uniquely visible in the old edition. The new pair of columns are uniquely visible in the new edition. All the other columns are visible in both. So that's what the rules assume, and it's this. These are the rules. A forward cross-edition trigger is fired when insert, update, and delete coming from application code is issued by a session using the old edition. And it's clear what the metaphor is. You go forward from the old miserable world to the new, clean, exciting, brave new world, don't you? And the other metaphor is crystal clear as well. If you're leaving behind where you'd got to and going back to the old miserable world, well, we didn't use the word back, we used reverse. So we have forward and reverse cross-edition triggers. So the forward trigger is the place you write your code, who in the phone number example will notice a change in the value in the old style and compute the two new values for the new style. And the reverse cross-edition trigger is the place where you put the code, who notices a change in either of the two new style columns, scrunches them together, and produces the value that will go into the old style. Yes? Simple as that. So a reverse cross-edition trigger is fired when applications do insert, update, or delete from sessions using the new edition. Okay? With me? Simple as that. And there's no more to be said about them.